Today, ladies and gentlemen, we're going to go ahead and take a look at sequences, just like we did in Chapter 5. And we're going to turn those sequences into a table. We're going to find the zero and the multiplier, and then we're going to write the exponential equation for this as well. And we're going to do a couple examples, and then we're going to do another example where we have a word problem and we turn it into a percentage to a multiplier using those rules we learned towards the end of last semester. So this is going to be basically our multipliers review. If you are having difficulty figuring out how to use a multiplier, you're not going to be able to do exponential functions. So we just want to make sure that this is nice and solidified in your brain. Okay, so let's go ahead and start with a sequence for example number 1. So our sequence is 6, 7.2, 8.64, 10.368, and we're going to go ahead and find the next term in that sequence. Okay. We're also going to go ahead and make from this an XY table with what we know. And we can already start this because we already know a number of items here. So we need to find our zero because we know that's a part of our exponential equation formula. So we know it's y equals a times b to the x. So we can go ahead and write down what we know, and then we're going to continue that pattern out. So we can see that our first term is 6, so we're going to write 1, 6. Our second term is 7.2. Then we move on with 8.64, 10.368. Now, we need to find our multiplier. We need to find what do I do to the number 6 to go ahead and turn that into 7.2. And we know that our multiplier has a very simple equation. We know that it is the next number divided by the previous. So we need to go ahead and pick any two numbers next to each other. It doesn't matter which two there are, as long as they are next to each other. So in this case, my next number is 8.64, and the previous number before that one is 7.2. So of course, when we're doing exponential functions, we're going to always want to have our handy-dandy calculator. So we have 8.64 divided by 7.2, and we can see that we have a 1.107. So we're going to go ahead and round this to our nearest tenth. So we have that is approximately 1.1, and that's what we're going to round our multipliers to as we go. So we know that in our equation is y equals a times b to the x power, and we know that our a is our 0, and we know that our b is our multiplier. And we just found out that our multiplier is 1.1. Oh, we multiplied it by 7.2, and I look at my calculator, and it's 7.8. So we need to make sure that we are doing that correctly. So that's one of the reasons why I always say, oh, make sure you're using a calculator where you can see your problem. So let's double check, and it is 1.2. So it's a good thing that we noticed that that was a little off there. Okay, so that one is already a terminating decimal, so that's even better. We don't have to round that, and so that is equal to 1.2. So what that means is to go from 1 to the next, we are multiplying it by 1.2. So there's two things that I can do. First of all, I can go ahead and extend this out, and I'm going to go ahead and take that last number, multiply it by 1.2, and I'll find the fifth term of our sequence. So 10.368 times 1.2, and that means that my fifth term is 12.4416, and I can transfer that over to my table as well. Now, I still don't have enough information for my equation. I do know my multiplier, however, I don't yet know my zero. So I'm going to do the opposite of multiplying by 1.2, which is dividing by 1.2. So I have 6 divided by 1.2, and I see that is the number 5. So my 0 is my number 5. And this information right here is what I'm going to use to finish up my equation. So I have my 2 pieces of information. I have my multiplier, which is a B, and I have my 0, which is my A. So I'm ready to go ahead and plug that into and find my final explicit equation. So I have y is equal to 5 times 1.2 to the x power. So because this is an explicit equation, of course, I can plug any number for x in my calculator and solve and know that that's the number in the sequence. Okay, let's go ahead and take a look at example 2. And like I said, there's 3 examples we're going to be working on today. So our example 2 is 2.4, 1.44, and 0.864. And as you can see, I'm getting smaller as it goes on. So because of that, I'm expecting my multiplier to be a number between 0 and 1 because it's an exponential decay and it's getting smaller over time. Let's go ahead and set up our table. Once again, always starting with 0. We know our first term is 2.4, our second 1.44, and our third 0.864. We're going to find out what that fourth term is as well. So once again, we're simply going to go take any 2 of them and go next divided by previous. So my next is 1.44 divided by my previous, which is 2.4. Once again, we're going to take out that calculator. We always want to use our calculator for these. 1.44 divided by 2.4, and that is 0.6. So 0.6, ladies and gentlemen, is my multiplier. And we know that's going to be the B in our equation. So we can go ahead and expand this out and find our fourth term by doing our 0.864 times our multiplier. So let's go ahead and do that. 0.864 times 0.6. And that gives us a 0.5184. And we can go ahead and expand that out down here on our table as well. Now, we have our multiplier. However, we still need to know what exactly is our 0. So we're going to do the opposite of multiplying by 0.6, and we're going to divide by 0.6. And that's going to give us our 0, which is our A. So once again, we take our calculator, 2.4, we're going to divide it by 0.6, and we get an answer of 4. Okay, now we're ready to go ahead and write our explicit equation. Once again, for exponential functions and geometric sequences, it's y equals a times b to the x power, with a being our 0 and b being our multiplier. So this equation is going to be y is equal to, our a is 4, and our multiplier is 0.6, and that's to the x power. So we have turned our sequence into the equation of our exponential function. Okay, we're going to go ahead and do a third and final example to remind us how we use multipliers. This is example 3. So this is going to be a word problem because that's usually when we see percentages with exponential functions or sequences. So in this story, we have $300, and that's in a bank, and it's increasing by 12% per year. And our question is, how much money will we have in 5 years? So we know we have $300 in a bank, and it's increasing by 12% per year. So we want to be able to figure out mathematically how much money will we have in 5 years. So a reminder back again from chapter 5, depending on whether we have an increase or a decrease in our problem, our increase is we go ahead and take our percentage, we change it to a decimal, and if it's an increase in our calculator, we go 1 plus that decimal. And that's going to make that number greater than 1, which means it's going to be getting bigger over time. However, if the problem tells me there's a decrease, it's going to be 1 minus that percent as a decimal in my calculator. So we take a look at our word problem. We have a couple pieces of interesting information. We have $300 to start with. If you start with something, that is your zero. So this is going to be our A in our equation. And then we need to go ahead and we need to change of an increase by 12% into a multiplier. So we go ahead and write our 12 down, and then we move our decimal point 2 to the left. We see that that is an increase, so we're going to have 1 plus 0.12. And so our multiplier is going to be 1.12. That's going to be the B from our equation. At this point, we can go ahead and make an explicit equation for our problem because we have two pieces of information we need. We have our zero and our multiplier. So our equation is going to be y is equal to our zero, which is 300, times our multiplier, 1.12 to the x power. Now, the question asked me, how much money will we have in 5 years? So we're going to go ahead and solve this problem, but we are going to substitute for x of 5. Now, remember as we're doing this that we need to use order of operations. And order of operations tells us that we do exponents before multiplication. So we're going to go ahead and solve this in our calculator first, our exponent. Then we're going to multiply it by 300 to find our answer. So let's go ahead and do that in our calculator, or you can have a tab open on Desmos. So I put in 1.12. I put my caret there, and it's to the 5th power. And then I press enter on my calculator. Now that is 1.12 to the 5th power. I leave that in my calculator. I don't want to round it too early because when I round it, I become less accurate in my mathematics. So I'm going to leave that in my calculator. It goes on forever and ever. And then I'm going to multiply it by 300. And that gives me my total. Now, because this is money and we know it's money, I'm going to go ahead and round it to make it look like money. So I'm going to go 2 to the right of the decimal point. So this tells me that in 5 years, I will have $528.70 in my savings account. Okay, so ladies and gentlemen, here are 3 ways that we use sequences or word problems with percentages as we are reviewing our multipliers, which is a key component of exponential functions. Let's go ahead and practice.